Okay, so what if I told you that AI's biggest weakness is actually its greatest strength? It sounds kind of weird, right? But today, we're diving into this absolutely groundbreaking paper that completely flips the script on how AI remembers things. And the solution they came up with? Well, it's as brilliant as it is bizarre.
I mean, just think about it for a second. An AI can basically read the entire internet, recall some obscure fact from a medical journal in like half a second, and then turn around and write a flawless legal document. This ability, this near infinite memory, it's what makes AI feel like actual magic.
But, and this is the big but, here's the twist. That perfect, flawless memory, it's also a crushing weight. Seriously, imagine trying to have a normal conversation, but you're also remembering every single word you've ever heard in your entire life. You couldn't do it, right? It'd be impossible. Well, for an AI, that's not just some philosophical thought experiment. It's a real computational nightmare that can bring even the most powerful systems grinding to a halt.
I mean, we've all been there, haven't we? You're deep into a really good chat with an AI, things are flowing, and then all of a sudden, poof, it's like it has total amnesia, and you're talking to a complete stranger again. It's so frustrating. But it's not a bug or a glitch. Note, it's a deep, fundamental flaw in how these things are built. And it has a name that sounds just as scary as it is: quadratic scaling.
So, quadratic scaling. It sounds super technical, I know, but the basic idea is actually pretty simple and kind of terrifying. Get this, if you double the length of your conversation with an AI, it doesn't need double the computing power. No, it needs 4 times the power. And if you triple the length, it needs 9 times the power. It just explodes. This massive exponential cost is exactly why true long-term AI memory has always felt like an impossible dream. Well, until now, that is.
All right, so how on earth do you solve a problem that's basically baked into the AI's DNA? Well, a brilliant team of researchers decided to ask a totally radical question. What if we're thinking about this whole memory thing completely wrong? And their paper, DeepSeek OCR, comes up with a solution that sounds like it's straight out of a sci-fi movie. What if, instead of remembering the words themselves, the AI could just remember pictures of the words?
Now, the paper puts it in this very academic way, saying they're leveraging visual modality as an efficient compression medium for textual information. Okay, so what does that actually mean in plain English? It means they're literally turning text into pictures to save space. I know, it sounds totally wild, but trust me, as you're about to see, this idea is an absolute game changer.
Okay, to really get why this is so revolutionary, we got to talk about tokens. Just think of tokens as the currency that an AI uses to think. Every word, every piece of information has a cost in tokens. So a really long piece of text, maybe a big document or a long chat history, that might cost, let's say, 7,500 text tokens. And believe me, that is a lot of computational cash to spend.
But now watch this. This is the magic part. What happens when we turn that exact same text into a picture? The cost absolutely plummets. We're talking down to just 750 vision tokens. That's a 10 times compression, a 90% discount. Suddenly, long-term memory isn't just possible, it's actually affordable. This, right here, is the core of the whole DeepSeek OCR breakthrough.
Okay, I know what you're probably thinking. This sounds a little too good to be true, doesn't it? I mean, how can an AI possibly read a picture of text as well as it reads the text itself? Well, the secret is in the incredibly clever way that DeepSeek OCR is designed.
It's basically this elegant 4-step process. First, you've got something called window attention. Think of it like a high-powered magnifying glass that scans the image of the text, picking up all the tiny little details. Step 2, a special compressor comes in and just squeezes all that visual info down, making it 16 times smaller. Then, for step 3, global attention zooms out to see the big picture, understanding the overall context, the forest for the trees. And finally, a super powerful decoder takes that compressed visual data and perfectly reconstructs the original text. It's like a little symphony of efficiency.
So yeah, it's a really cool theory, right? But the big question is, does it actually work in the real world? Well, the researchers didn't just stop at the idea. They put this thing through its paces, and the results they got back were, honestly, pretty astonishing. Just look at these numbers. They're staggering. When they compressed the text by 10 times, the AI could still reconstruct it with 97% accuracy. Let that sink in. You cut the cost by 90% and you only lose 3% of the information. That's incredible. And even when they pushed it to a crazy 20 times compression, it still retains 60% of the original text. This is way more than just a proof of concept. This is a full-on paradigm shift.
And it's not just about how well it reconstructs the text either. They put it head-to-head against other big AI models on a standard industry benchmark, and DeepSeek OCR basically blew them out of the water. It got the best score, but here's the real kicker. Look at the resources it used. Less than 800 tokens. Its closest competitor needed almost 7,000 tokens to get a worse score. It's kind of like having a supercar that has the fuel economy of a little scooter. It's the best of both worlds.
But really, the implications here go so much deeper than just saving some money on server costs. This is about fundamentally rethinking what AI memory even is. It's about making it less like a perfect, cold machine and, well, a little more human. So you really have two different ways of looking at AI memory. On one side, you've got the old way, perfect, total recall of every single detail. The problem? It's incredibly slow and expensive to maintain. But on the other side, you've got this new, more human-like approach. It's super fast, it's really efficient, but it has this one fascinating little quirk. It forgets. And that ability to forget might just turn out to be its biggest advantage. So how does an AI forget using this system? Well, it's actually a really beautiful and simple idea. A conversation you just had gets stored as a sharp, crystal clear, high-resolution image. But as that memory gets older, the image gets compressed more and more. A chat from a day ago might be a little less sharp. A month ago, it's getting kind of blurry. And a memory from a year ago, it might just be a tiny, highly compressed thumbnail. It's this graceful, gradual fading that works a lot like our own memories do.
So, why does all this matter? Look, this is so much bigger than just a clever trick. What we're looking at here is a brand new path to solving one of the biggest, most fundamental problems in all of AI. This could make incredibly powerful AI models way cheaper and more accessible for everyone. It's a huge step towards AI that can actually forget things intelligently. And that opens up the mind-blowing possibility of AI with a theoretically unlimited context window. An AI that could learn and grow over a whole lifetime, just like a person. It's just amazing. By leaning into what we would normally call a flaw, an imperfect memory, these researchers have unlocked a completely new level of capability for AI. And it really makes you wonder, doesn't it? What other human weaknesses might actually be the secret ingredient for the next big AI breakthrough? I'd love to know what you think. Drop your ideas down in the comments.